So far you've learned how to solve linear systems using graphing and substitution. Now we're going to take a look at elimination. So for elimination, really what we're doing is we're trying to cancel out one of the variables in order to solve for the other, and then taking it and substituting it back in. So there is still some type of substitution going on here. For number one, let's say I wanted to cancel out one of the variables. We're going to be adding the systems together each time. If I take a look at the x or the y, you can see that if I'm adding the two systems together, the two x's already cancel out because 2x minus 2x is 0x. So it makes sense to go ahead and cancel out the two x's. And then negative y plus 3y is 2y equals 1 plus 5, which is 6. So we're combining like terms from this step. Let's continue and solve for y. So now to get y by itself, we divide by 2, and we have y equals 3. We're going to take that y equals 3 and plug it back in to one of our original equations. Sometimes it's easier to plug y into one equation rather than the other. For example, if I were to take this y value of 3, I would probably want to plug it into the first equation because you could see how then it would just be 2x minus 3 equals 1, and I can easily solve that. If I were to plug it in the second equation, I'd have to multiply 3 by 3 first and then begin solving. Still not difficult, it's just a little bit easier to use the 2x minus y equals 1. Now I'm going to plug in 3 for that y value. So really that's 2x minus 3 equals 1. And then I solve for x. So add 3 to each side. That gives me 2x equals 4. Divide by 2. X equals 2. Same as the other notes, when you find your final answer, you want to write it as a coordinate. Remember, a coordinate is x comma y, so 2 comma 3, and that's your final answer. Okay, let's take a look at number 2. It's already set up for the y's to cancel, so let's go ahead and cross those off. Adding the two systems together, I get 3x equals 18. Divide each side by 3. Notice how you get x equals 6. Alright, now that I have one of the variables, I'm going to plug it back in to solve. You see how that first equation is probably easiest because x is already by itself. It's 6 plus 3y equals 12. Once again, I took 6 and I plugged it in for x. That's how I got that. And I'm going to solve for y. Gives me 3y equals 6. Divide each side by 3. Y equals 2. Remember to write your final answer as a coordinate. So 6, 2 is the final answer. Let's take a look at number 3. So number 3, it's not set up for something to cancel right away. We could try and cancel the x's, but in order to make them the same, I'd have to multiply both equations by something. However, if I try to cancel the y's, we have a positive 3y and a positive 3y. If I want them to cancel, I'm going to have to multiply one of the equations by a negative 1. Because if I multiply 3y by a negative 1, that would give me a negative 3y, and that can cancel it out. So once we get to something where they don't automatically cancel, we have to multiply one or both of the equations by some number to make them cancel. If I multiply that by negative 1, and it goes to each term, my first equation is now a negative 2x plus 3 or minus 3y, excuse me. Fix that. Minus 3y equals negative 1. And I'm just going to rewrite my second equation because I didn't have to do anything to it. Now you can see how the y's cancel. I'm going to add these two new systems together, so that would give me 3x equals 15. Divide each side by 3, I get x equals 5. You're going to take x and plug it into one of your original It doesn't really matter which one in this case, so I'm just going to plug it into the first. 2 times x, which is 5, plus 3y equals 1. That gives me 10 plus 3y equals 1. Subtract 10 from each side. Gives me 3y equals negative 9. Divide by 3, y equals negative 3. Remember to write your final answer as a coordinate. So 5, negative 3. All right, let's take a look at number 4. So for number 4, once again, we want to cancel out the x or the y. It doesn't really matter. When I look at this one, let's say I want to cancel out the x's. I could multiply the first equation by a negative 3 in order to cancel out the x's, or I could multiply by a positive 2 to cancel out the y's. So really, it's up to you what you would like to do in order to solve and what variables you would like to solve for first. I'm going to go ahead and just multiply by 2 because I think the arithmetic for multiplying by 2 is a little easier than by 3. But again, it's all just personal preference. So if I multiply by a positive 2, that gives me 2x plus 2y equals 6. The second equation I had left alone, so I'm just rewriting it. Remember, you're adding them together. The y's cancel. I'm left with 5x equals 10. Or if you divide each side by 5, that's x equals 2. I'm going to take the 2 and plug it back into one of the equations. I personally think the first one's a little bit easier because x is already by itself. So 2 plus y equals 3. Subtract 2. Y is a positive 1. So the coordinate is 2, 1. Number 5, when I look at this, again, doesn't matter if you want to cancel the x's or the y's. Let's say I wanted to cancel out the y's this time. All I would have to do to cancel out a negative 2 is make that a positive 2. So I'm going to multiply by a positive 2. Rewriting the first equation, I get 4x plus 2y equals 16. And then you could rewrite the second equation, or you can see that it's right there. Either way, if I'm looking at these two equations, notice how the x's cancel and the y's cancel. So I have nothing left. That's 0 now. They all canceled. On this side, the 16's cancel. I get 0 equals 0. That is a true statement, so there are infinitely many solutions. Number 6, it's probably going to be easier to cancel out the y's. If I wanted to cancel out the x's, I could multiply this by a negative 4 and this by a positive 3. Or I have a negative 4y here, so I could just multiply this by a negative 4 to make that y a positive 4. I'll show you what I mean. Here's the first equation. When I multiply the second by a negative 4, I get negative 16x plus, because there's negative times negative, 4y equals negative 80. Okay? The y's canceled. That's what I wanted. That gives me negative 13x equals 2 minus 80 is a negative 78. Divide negative 13 on each side. That gives me x equals a positive, because 2 negatives makes a positive 6. Take that x and plug it into one of the equations. It's probably this time going to be easier to plug it into the second, because if I'm solving for y, you can see how y isn't being multiplied by anything right now. So I'm going to do 4 times x, which is 6, minus y equals 20, and I'm going to solve. So 4 times 6, that's 24, minus y equals 20. Subtract each side by 24. So that means I have a negative y equals a negative 4. Now I don't want a negative y, so I have to divide or multiply each side by negative 1. That gives me y equals a positive 4. So the coordinate is 6, 4. For number 7, we have two systems. It probably would be easier to try, and I don't know, I see the 3 pops out to me. on the y's, so I'd have to multiply, get them differing signs, so multiply by -3. That'll give me a -6x plus 3y equals -12. Now, what I notice is the x and y's cancel, so I have 0 equals 10 and -12 is a -2. Now, this is a false statement, so that's no solution. Number 8 actually is very similar. If I were to multiply by, let's say, a -2 to cancel out the x's, that's -10x plus 4y equals -6. Those cancel, but then this one should be, that's going to be 0 actually. So that's 0 equals 0, infinitely many solutions. So we already did a problem like that in number 5. Number 9. Now let's say I wanted to cancel out the x's. It really doesn't matter. The x's are probably easier than canceling out the y's because here I can multiply by 3 and multiply by 2. So I'm going to have to multiply both equations in order to cancel them out to get it to a -6x and a +6x. Otherwise, I would have had to multiply by a +5 and a +7 in order to cancel out the y's. The first equation would become a -6x plus 21y equals 6. And the second would become 6x minus 10y equals -28. If I were to add these together, we can see how the x's cancel, and I'm left with 11y equals -22. Divide by 11, y equals -2. Take it and plug it in. Really, it doesn't matter if you want to plug it in the first or the second. I'm just going to go the second because I don't like how that x is negative. Just personal preference. So 3x minus 5 times y, which is -2, equals -14. 3x plus 10 equals -14. Subtract 10 from each side. 3x equals -24. Divide each side by 3. X equals -8. So the final answer is -8, -2. At this time, you're good to go ahead and begin your homework.